Hello, welcome to number 3, light interference. Just a quick video to have a look at everyday occurrences where light shows its wave property, and that being the fact that it interferes with itself, or light can interfere with light. So some examples: soap bubbles. You get all this iridescent colour on a soap bubble, and that's because it's acting like a thin film, and it's causing the light that enters at different points to interfere. Oil. Here's a droplet of oil on wet asphalt, and you can see this range of colours coming across here, and that's interference as well. Peacock feathers. You may not think of that, but they're designed to give these bright iridescent colours because you're getting interference from the light that goes in and bounces around and comes back out. Butterfly wings. Some butterflies are very brightly coloured and have a sheen to them, and that's how that works is the butterfly has lots of scales on its back, and the scales actually look like this. The butterfly doesn't actually have any colour to itself, or it doesn't have any pigment. May have a primary pigment, but the whole range of colours is not due to pigments. It's because the light comes into these scales, bounces around and then bounces out again and interferes, and you get bright variations in their colour due to that. And people have been trying to make artificial imitations of these, and the main purpose they see for it, or they did when I was reading about this, was in makeup. They were going to make makeup that sort of changes colour and gives an iridescence. I don't know if it's actually happened, but they were researching how to do it. Opals. Opals are a silicate that forms in rocks where weathering has occurred, and if you've ever seen an opal, they shine and you can see all sorts of different colours in them, and that's because of light interference from the structure within them. Seashells. Now, looking at the seashells, maybe if you've got a big abalone, which you get around Tasmania, you can see colours inside the shell. Used to be called mother of pearl. People used to make buttons and various things out of it, cigarette cases and things. And you can see here, this is a company that makes tiles out of mother of pearl, and there are all these different types of patterns depending on which sort of shell it comes from, which is all giving that colour, that sparkle due to interference of light. And some minerals can also show that characteristic. And lastly, beetles. Every Christmas we get Christmas beetles, and some of them can be very brightly coloured. Here in Tasmania we have a couple of ants that are very brightly coloured, great big things. And that's all because on their carapaces they've got some microscopic structures, and those structures cause the light that hits them to actually interfere with itself and give you those colours. Most of it's not due to pigments at all. Alright, so quite a few everyday examples of light interference. In the next video we're going to look at electromagnetic radiation and the electromagnetic spectrum. See ya.